What we have here is a motor that can run continuously forever because you run it on one stack of batteries and you charge up another. So this is a combination motor generator. This is what I'm into now. You have a little motor right here. Now the way the motor works, it's a pulse motor. So what you're doing is you're turning it on, making this electromagnet have power so it pushes the magnet away. So what I'm doing here, if anybody wants to know the circuit, is I take the battery, put it into the coil, and then just before it gets to ground, I put a switch on it so it turns on and off. And here's the switch right here. It's a magnetic reed switch. It's a switch that's controlled by a magnet going by it. This flame that happens inside this reed switch has a lot of power to it. It should have as much power in there going in as coming out, because every time that coil turns off, all the energy contained in the coil comes kicking back. Now you can take that energy that kicks back and put it into a second battery and charge up a second battery. So now there's this flame here, and to make it vanish, conventional electric motor bills will just ground it out or something. But what you want to do is you want to put a full wave bridge rectifier. It's this component you can get at Radio Shack for $1.50. It changes AC into DC. Look at that baby go. Here's the battery being charged here. Watch the volts on it. See, look at this. 12.65 already. 12.66. See, it's going up. And it's going to go all the way up. It's going to go all the way up to 14 if you want. So a few days ago, I ran this motor for 50 hours. And I rocked the batteries forth. I switched them back and forth about 3 or 4 times. And at the end, I still had like 12 point something volts, and I could have gone a lot longer. So what this is it's a motor. I call it an Overunity motor, in that you're using so much power and you're always charging up another thing. So you always have a stack of batteries being charged when you run out of your batteries on the other side of the system. It's like the simplest thing in the world. And it's a motor, which means you can turn a generator with it, and now all the electricity the generator makes is free. Or you can turn a water pump with it, or anything you want, or a car. You can stack these. You can make 12 on a shaft if you want. So that's what I'm looking to have, is like a commercial unit people could buy in a store, something like this. Just something that runs on car batteries, charges car batteries, and you have excess power with a generator to do whatever you want with. So it's free energy, because you don't have to pay for it. It's just happening. It's free. Thank you. How about that? Oh, there it goes. Okay, thanks. Thanks a lot. This is really fun. Everybody's really nice. The food's great, you know. And I have Kobe helping me here, and she's going to be the magnet girl and pass things around. I don't have any patents. Help. I think in free energy, patents are a really stupid thing to get, and they won't give you a patent anyways. And also, when you release things to the internet, you're releasing it to the public domain. So that means that you cannot patent it. You go to a patent lawyer, they say, well, have you told anybody about this yet? You know, oh, no, you know. But you go to the, as soon as you release it, that means nobody can patent it, because you've released it to the public domain. It also means yourself can't patent it, but who cares, you know? This is free energy. I found whenever I follow the dollar, like, oh, God, I'm going to make $1 million off of this, you know? Every time I follow the dollar, nothing happens, okay? There's something about money and these things that don't coincide. These things also, if these get all over the world, I'm not the only person making free energy motors. What I'm doing is I'm making something that runs on car batteries, because I can't think of a more universal power source than car batteries. They're all over the place, and everybody throws them out all the time. And if you can keep, and you know, everybody knows when you have a car, you can keep your car battery going for 5-6 years or something before you have to get a new one, as long as you keep it charged up. So that's pretty good. If you can have an energy system in your house going for 5 or 6 years before you got to replace the batteries, can't go wrong. And if you want to be real scientific, you can get rid of the batteries and you have huge capacitors. Just these capacitors store electricity, and you can have capacitors, you know. But I'm trying to make this universal. It's like a hardware. I'm a traveling hardware store. I get all the stuff, well, I have the plastic cut at a plastic store, but mostly I make my things out of stuff you can get, like at Radio Shack and Home Depot or something like that. And the whole idea is I want people to make these motors themselves, because I really don't think any big company who's trying to make money is ever going to pull in and say, oh yeah, we want to make it, because they're going to, if this gets out in the world and it gets to be really popular, that means everybody can disconnect themselves from the power supply and everything else you can think of. You can do space travel, you can do space colonization, everything. You know, it's just incredible what you can do if you have free energy, if you just think about it, you know. So you aren't supposed to say free energy, you aren't supposed to say, there's a bunch of words for it. So people ask me what it runs on, I say it runs on confusion. So, and it's actually kind of true, because what you're doing, this motor just pulses here's the way it works. You have electromagnet here, an electromagnet here, here and here. So you have an electromagnet here. Electromagnet is like a core, like a steel core. I just use bolts I get at a hardware store. You wind electric wire around it. It's called magnetic wire. Magnetic wire is regular wire, but it has a thin coat of enamel insulation on it. And so it doesn't short out when it touches together. And you wind this up into a coil, and now when you give it a little bit of electricity, you have an electromagnet. And everybody knows what electromagnet is. You give it a little bit of juice, you can pick up things that are steel, cars and stuff. So I have an electromagnet here. See that? They're coming like this. In the middle here, I have two electromagnets also. And here they are like this. See that? Right in the middle. I don't know if you can all see that. Right there. Now, so what you do, this is the whole trick, and they don't have anything in the textbooks about this. No, they don't even print this in the textbooks. What you do is you have north against north coils. The coils, you wire the coils up so that you have the north going bammo, and the one that coming is a north. It's a north-north, so it's like, you know, you push them together, and you just turn the juice on just for a millisecond, which is 1,000th of a second. And when they line up, see they all line up? Now this is going to be north, 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 north. So you got a bang, bang here and a bang, bang here simultaneously. That'll fling the rotor like that. That's the way it works. Now what happens? Oh, I don't know if I should get going on that too much. Okay, this is the theory. Okay, so you all understand how this motor runs. It's revolving electromagnets, two of them, and two outside ones. It's very important, this is real important, to have these windings exactly the same. You want to have the same length of wire, the same thickness of wire, the same winds. You want to have the same cores, because when you collide this, what it is, it's a magnetic field of flux. It's a flux, it's rotating. Flux is you know, magnetism. It's the invisible force that picks things up, flux. And it's actually lines. It's not a big old cloud of flux, it's lines in a particular pattern, but don't worry about that for now. So, but this is rotating. So if you can imagine, this one will rotate. Now this one's going to counter-rotate into it. So you have a revolving magnetic fields that corkscrew into each other. So what happens is you have this force that actually compresses like a pogo stick. It's a magnetic force. It goes like this. And it also stops the magnetic field rotation, because if any of you have studied electricity or just read a book a little bit, there's things associated you always have with electricity. You always have heat. You always have a magnetic field rotation around your wire. Is a thing called the right-hand rule. Electricity goes through a wire, current, and it rotates. There's this field that rotates around it. You always have that. It's just part. And so the thing is if you can make the magnetic field stop rotating, that means you can make the electricity also stop flowing, which means you aren't drawing anything from your battery. So that's a very good thing to have. Now, what's good about this motor is you got a collision here, and at the high point of your power, like when you get the most kick in this motor, that's when the current turns off, which is like the best of both worlds. Because you have a colliding, and it actually freezes the current for an instant and stops it. And so that's one reason you have very little power draw. Now, the reason you have to have them exactly the same is if you have one bigger than the other, if you make a big electromagnet here and a small electromagnet. Okay, now this is what I call a chassis. And this is what rotates inside there. See that? It's a neat little thing. And these are easy to make. I go to Home Depot. It's a little PVC pipe right there, a little cap right there, a little stainless steel coupler nut. It's stainless steel here. You get the magnetic wire. You get it at Radio Shack. You get it in its little spools. It's about $4. They sell them in 3-packs. I like to use the gold, so put that in there. And now when you look at this wire, you'll see it's got kind of a coating of enamel varnish on it, and that's the way magnetic wire is made. When you wind those coils, you don't want the wires to touch, and it's just at the very end. So it's a little insulation on there. It's called magnetic wire. So that's what I wind the coils with. And now what I use, this is kind of a trick I came up with, is if any of you have taken part in an alternator or seen electric motors, they usually have a little brush, a little carbon brush that'll wear out in your alternator. A lot of times you replace that and your alternator will work. It's a little, I brought one of those to show too. I don't know where it is, but anyways. Now that causes drag and it also wear out. So what I do is I actually send the electricity through the bearing itself, because it's made out of steel, and they have conductive grease. They have grease that's conductive, so I fill it with conductive grease. So I actually send the electricity through the bearings. Now, if I was using high voltage or something, it would eventually fry these bearings out, make them turn black and stuff. But we're only using less than an amp going into this every time, and this thing really flies. Wait till you see it go. It really goes fast, and it charges up a battery really good, while it doesn't even drain the battery running the motor. In fact, we're testing it over there, and we got both batteries going up just a little while ago. So you can't go wrong with that. So I call this, for a purpose of this thing, it's a rotating battery charger. So if you guys want to build one of these, I would prefer people just to read my website and then just go out and get all their parts and build it themselves and just email me and stuff and ask me questions. Because it's hard for me to put a kit together and deal with customers and do all this stuff, because I'm really just someone who just builds these things and does that. But if you want to, I'm holding a workshop on Monday, and I figured I have enough to build about 6 motors, and then a whole bunch. I brought a whole carload of parts, But what I want to do is I want people to build these motors for themselves, because it's kind of an unsafe thing. A lot of people say you're going to get killed when you deal with this, and they give me lists of names of people who disappeared when they deal with free energy and stuff. Oh, yeah, it's pretty true, These guys are serious. So, because it's going to put everybody out of a job, for one thing, won't it? Because, you name it, it's going to ruin everything. And so I don't mind that at all, really. So here's the idea. Now, if any of you really want to get one of these things, put it in your house, you get one of those inverters. You go to a car store or a marine boat store, you get an inverter. It takes 12 volt into 110 horsepower, and you can run your computer and lights and whatever you want from it. So what you do now, when we run this motor, there's going to be 2 things. There's one running the motor, there's one battery running the motor, and there's one getting charged. Now, the one getting charged, you put that inverter across it. And then now you have house power. So you could actually run this overnight in a closet or something. When you wake up in the morning, you got a nice charged up battery. Now you can run your house off that charged up battery, and then you can run your motor. You can imagine. You can see what's going on here. You can have cars without any fuel. You just have cars that charge up their batteries as they run. Like, duh. So yeah. I told you I was going to. Okay, well anyways, and it goes on and on. It goes on and on. A guy in Germany, so a lot of people built these motors, because I've had the motor on the internet for like about a couple years now. For about the past 2 years, I first got like a really Overunity motor going about 2 years ago, and basically nobody believes me, anything I say, I wrote a song, nobody believes a goddamn word I say anyway, okay? And it's very true. A lot of people will just say, what are you talking about? You can't do that. But the basic science law to always remember, for every force, for every function, you have an equal and opposite dysfunction, okay? And this is true also, okay? Because when you put electricity into a coil, what comes back is going in the opposite direction. It's like you eat something and you vomit it back out. God. Okay. Hey, please don't laugh anymore. I mean, God. I'm telling you, I can't. Okay. So, okay, we're going to pass this, we're going to pass these parts around. Okay, so this is the chassis. You can all take a look at them. You can see how easy it is to build. It's stainless steel through here. This part of the chassis and this part of the chassis is not electrically connected. If you took a wire, it wouldn't connect there. This plastic insulates it. So I have a bearing here and a bearing here. So I send the electricity in this bearing. It goes through the coils and it comes out the other bearing. It's a real neat thing. So, and this is a little copper tube here that makes contact. So I have some here. Also, this one here, it's called a bifilar one. Instead of winding a coil with just a single wire, you wind it with 2 wires together at the same time, all the way around. So now I have 4 bearings on this one, and this is a real neat, if you look at it, you can fool with it when you get it. And one of these bearings is connected to the shaft, and one of them is riding all on its own, insulated with some nylon washers. So here I have 4 conductors. I have 2 here and 2 here. And you can do a lot of tricks when you have double wires. You can have 1 battery. But anyways, this is a bifilar. You can have 2 batteries running it, and one works like a generator while the other one's driving it in. But that's all something else again. So I guess, oh, here. And this thing right here. This is a little magnet. And I'll turn this around right here. This is how you fire this motor. It's a pulse motor. It only draws current when... See those rotors? It only is like from about here to about a 1/4 inch away, maybe only 1/8 of an inch. All the rest of the time it doesn't even draw current when it's turning. It just goes just a little bing and it spins. See that? You can see right away that it's not going to draw much current at all in the first place, no matter what I'm saying, you know. So, whatever that is. So, so anyway, so here's the... Here's a magnet, and this goes on back here. It's attached to the shaft, and it spins around. This little magnet on the end trips these things. There's little things they're called magnetic reed switches. They're really neat little things. They cost about $4 or $5, and they're little tiny tubes. They have a little piece of metal in there that's attracted to magnets. When this magnet passes by, it pushes those little leads together. It's inside a little tiny vacuum tube here. They're called magnetic reed switches. So when this magnet passes by that little reed switch, it trips it. It does a little impulse. And that sends the current through this relay down here. You don't know what a relay is, but it's just basically a big switch down here. So this controls it. See that? So you can see right now it would go click, and it would be nothing on, then click, something on, and then nothing on, and then click. See, so it's just a little click, 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 click as it's spinning. So it doesn't... we figure it's about 10% of the rotation is the only time that you actually draw electricity into the motor, for only 10% of the time. So right away, you can see how efficient this motor is. And then there's something called ringing a coil, just like a bell. The way, you know, let's say you have a Liberty Bell or something, you hit it. If you hit it too hard, you won't get a good ring out of it, or if you dampen it when you ring it, or if you don't hit it hard enough. But the coils are the same way. A coil is just a wound up wire is all a coil is to make an electromagnet. You just barely pulse it and just barely hit it, and you'll make those things ring after you turn the power off. And so you get a lot of ring of and that's power when the coils are still energized after they've been turned off and they're ringing. So anyways, so that's called ringing a coil. And so the thing is between the pulses, everything's still energized, and it's still like, yeah, going like this, you know, because it got hit, and then it's going, and it's dying down. It's called oscillations, what electronics would call those things. So you can tap that energy and so you get energy between the pulses. Now, that's what this is when you see that. And, oh, one more thing. There's a little slot here. This is really a kind of a cool thing if you're into these motors. There's a slot here. Now, if you have this slot sideways like this, it actually won't trip the little switch at all. But if you have it straight up and down, it'll like trip it fully, like with complete magnetic force. So what this does is it gives you an adjustment of how much power you want to put into your motor by twisting this little magnet from off, all this adjustment in between, and then full straight on. So it's really a neat thing, because you want to find that ring, you want to find just the sweet spot to everything where the thing just, you know, just give it a little juice and it just really takes off, you know. So, and then here's another cool thing, is this is all on a plate here. And you loosen this up, and while the motor's running, you can rotate this plate just like a distributor cap in a car. And you can adjust your timing to the exact point when it actually draws juice, when everything's lined up. So it's got adjustable timing, and it's also got adjustable pulse width, you'd call it, the width of the pulse, you know, how long the pulse lasts. And the coils will never get hot. You should think they'd get hot, but when you pulse coils really fast, they stay cold. It's just the way they are. But it doesn't take much, just 1 second. If you leave this on for like a whole length of a second, the coils will get hot. So you have to have a really short little durations, and they don't ever get hot when that happens. So I'll talk about one more thing just while you're listening. And so anyways, now this is something on the internet. These German guys really wailed on me. They're calling me an idiot and don't know what I'm doing, say I don't know anything about electronics, blah blah. Yeah, you know, poor me. And then they're telling me by their calculations this should be drawing 20 amps, you know, every time it pulses, you know. But I know it's only drawing about like 0.2 amps, like, you know, like actually 0.7 amps is what we just saw it was doing. So it's not even drawing an amp. And this is not including, they call it the duty cycle. When I was saying this only draws 10% of the rotation, so what you do when you figure out the draw to these motors, you look on a meter, it'll say 0.7 amps, but it's actually 0.7 amps in the pulse, where the pulse chops, and then it turns off, and now you have 90% of the time nothing going on. So when you figure out, the way you figure out power is watts, and the way you figure out watts is voltage times amps. So when you figure out watts to this motor, everybody wants to know what's the watts in, what's the watts out, because that's power. It's voltage times amps. It's just the way, don't ask me why, I don't know. That's just what it is in electronics. So when you figure out watts on this motor, you don't, if it says, let's say it says 1 amp, and it says 12 volts, and the volts you put across your battery, how many volts is it? 12 volts, duh, you know. And then you look and you measure, I won't say how we measure amps now because it's a little complicated, but you measure amps, and it says 1. So now you would say, anybody would say, oh, it's drawing 12, that means it's drawing 12 watts. This is a 12 watt, like a 12 watt light bulb or something. But it's not. It's drawing 10% of 12 watts because it's only taking power for 10% of the time. So a lot of people don't, let's call it time constant. A lot of people, they think mathematics, but they don't think about time. So, but when you figure time into this thing, because it is a pulse motor, now you have 1.2 watts instead of 12. And that explains why it's not pulling the battery down too. If it was 12 watts, you could just see the battery just go whoo, like this. But anyways, so I just want to tell you that. And now, I came up with this thing. These Germans, like I was saying, they're getting really mad at me. So I got really mad at them. You ever been mad on the internet, you know? And your hands shake, and you just, yeah. So that's the way I was with this guy. Because, like, he's doing it publicly on these science boards. I know now, this was a few years ago, I know now you just ignore everything. If you try to respond in the internet, it makes you look bad, even if you're in the right. Everybody knows that by now, you know. Don't ever use cuss words, stuff. Yeah, it just makes, even though they're appropriate, don't. So that's what I did. So anyways, so I got really mad, and I just started working on my motor real hard, and I came up with this new thing, and nobody else has it. And these are these permanent magnets right here, these black squares here and here. Now what happens is, first I've all told you about this north-north collision of the coils. That's the power, and this thing happens. But now when that turns off, right when it turns off, there's this enormous kickback of all that energy that's been wound up in that coil. You turn it off, it follows the path of least resistance, and it also comes back the opposite direction. Bango, that's what I was saying. You eat something, you vomit it. It is actually what electricity does in a coil. You eat it and you vomit it back up when you cut your turn. So anyways, so these magnets speed the thing up like 4 or 5 times. And just, we got this really strong magnet over here, and we're going to fool around with it. It's really fun. You can put it about here. I think if I was to make these to sell, I wouldn't sell these because they're too dangerous to even send on an airplane or anything like that. But they're really fun to play with, so we'll do that later. But anyways, these permanent magnets are kind of what make my motor unique than other motors because when the power is turned off, the power has been turned off, and all of a sudden it hits this permanent magnet and just, whew, it just sends it flying. And it's all when the power is off. And so the more magnets you can get on here, the more power you get. And also, when you have a coil go past a magnet, that's how you make electricity. So you're producing electricity, and you're making the thing go faster with these permanent magnets right here. And they're right here. And I actually have those on a plate, too, that adjust. Because if you were to put a mechanical load on this shaft, it would slow things down, and that point in time where you want those magnets to be would adjust. So that's just kind of the design things of this thing. So that's pretty good. So for now. Yeah.
What about this one?
Yeah. Oh, let me show. Okay, this right here, if you're wondering, I call this a rotor, and this is what spins around. See this? Now, this is stainless steel in the middle. You don't want to have a solid core here. You want to have this all, stainless steel. It does not become magnetic. So you want these magnetically isolated from one another. This side and this side. So whatever. You look at this. These are things you put on. When it gets really going, centrifugal force will start making things fly out. So I put these caps that kids, they won't electrocute themselves on, safety caps. That's what I actually have on the surface of this. And these are bifilar. If you look at it, there'll be a red wire and a gold wire, and I wound these double wires. You can do a lot of tricks with bifilers, but I won't get into that right now. And also, I don't just wind these just back and forth, like just wind it like you buy a coil in a store or something, just back, and forth. I make them directional, and if any of you are musicians and stuff, there's a unidirectional microphone. There's microphones you can hold right here and it'll pick up everything in the room, and then there's microphones that just pick up a focus right here like a singer would want. It's called unidirectional. So same with this. You don't want all this flux going everywhere. You want to concentrate it on what's happening and get all the power right where you want it. So when you wind these, you wind the coils all one way and you pull the wire back, and then you go forward the same direction all the time, and you pull the wire back and then go forward, pull the wire back, and you insulate it. So you'll see there's kind of a hump to this. And I pulled the wire back on the same way. So anyway, so these are the coils, and they're fun to wind. There's no big deal winding these. I mean, if anybody wants to make any of these motors, and you don't need to have these relays and stuff. You can have mechanical commutators where you just have like a piece of metal or a brush contact another piece of metal, just mechanically, not solid states and all this reed switch. You can make motors like this, and it'd be a lot cheaper. Now, this is one of my inventions. I put Teflon on here so there's no drag, riveted it on. And then I have these copper rollers, and I have 3 bearings inside of here, and I stuffed them with conductive grease. So this is another way to make electricity go into the motor. And now you put like 3 batteries together for 36 volts or 24 volts. You can get it like a strobe light. It's just big, intense flash going here. And now what happens too? Oh, I don't think I should really explain this, but you can make your own battery run in the motor, go up in volts like 15, 17 volts while the motor's running by using these, not these MOSFETs. Because all that backflash I was talking about before, it fills up and then you cut the current, it comes back. It's very intense and usually blows up everything. It's so intense. It's true. Most people, the spikes, big, huge spikes, come back. But anyways, that becomes an actual arc through the air, a flash you'd see in the air. And when that happens, it creates kind of a vortex, a salud. So that's Mexican for health. You know that? You're always supposed to say that to Mexicans, and they say thanks and stuff. But anyways, I just learned that. Yeah, salud. Okay. What was I talking about? The backflash. Okay. Okay, it's called the Chernetsky effect. There's this Serbian spy guy. he came over and when I was in Dallas, he was from Yugoslav. I think he was working for the Serbian government, but I don't care. His name's Venislav. He's a nice guy. I don't care if he does or not. And so he took a class from this professor named Chernetsky, and it's called the Chernetsky effect. So you all know about tornadoes. Okay, tornadoes is a vortex, right? Something spinning. It draws stuff up in the air. Now, whirlpool, it's drawing stuff down into the ocean, right? Now, if you can get a vortex happening with electrons, now maybe you can draw electrons from the surrounding environment into, because there's electrons everywhere right now, all over the place, you know. And so if you can take those from out of nowhere and put them in your battery, you're going to charge your battery up. And so what you do is this flash that happens, this is how it was explained to me. So if you go to a really clear water, like in a swimming pool with the sun shining down or something, you put your hand under there and you shove your hand back in front, you'll create all these bubbles behind you. And ship propellers, boats, they call it cavitation. And it's these bubbles that are created from inside the water. You know, everything's underwater, but you create air bubbles because you're shoving it there, and you create these little, like behind a semi-truck, you know, and you hit by those whirlpools that throw your car off the road. So so it's the same thing with electricity. Now, if you shove electricity through the air like a Tesla coil, you know, bzzz, like Frankenstein or something, when that goes through the air, if you get that, what you do is you get that gap to be just where it wants to be, and it'll like go through the gap, but it won't go back the way it came. It'll just keep going one way, and it works like a diode. A diode makes electricity go one way through the air. And so it'll draw electrons from the surrounding environment in little vortexes, and they cluster up, just like those bubbles when you put it through there. And so that's why you can get your battery to charge up by using these mechanical commutators. And the other way I do it is I use these things called splatter coils. I call them splatter coils. They're on my website. And what happens is this is north against north. And so all this stuff comes out the side. When I was in Dallas, this is a sick joke, but I was in Dallas, and I was talking about President Kennedy, and some guys say they got shot simultaneously at the same time in the head, and his head exploded all sideways like this. So I say that's the same thing happening here. It's a sideways thing like this. They didn't think it was funny in Dallas at all. So, anyways, so what was I saying? Okay, so that, see now, not only this isn't just flux going in and out. This is flux that has been compressed and it has been stopped, and now it's like being kicked backwards. It's an amplified flux. And so I found out, this friend of mine was telling me about this, I can do something. So I was just checking this out, and I could, with just one of these little coils, these are solenoid coils, 110 volt solenoids. I got surplus. They're like runoff house power, and I think they're for irrigation things or something. I'm not sure what. But they have very, 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 very thin windings, very thin, thinner than hair. And each of them has a bunch of windings, and I put a steel core in there. And just holding one of these, and you hook it to an AC meter, I can get it to read 7 volts on a meter by sticking it on the sides of my motor because of this north-north collision. This is something that's also unique to this motor, and other people who build motors, I always tell them, you got to try some splatter coils on there. There's other ways to collect this, but what you're doing, you're collecting flux that's normally wasted and just goes off into the air. Okay, now you take about 20 of these and you run them all in series. And now you'll have just an enormous amount of volts, and it'll also be big, huge spikes happening too. And you can get it to go, bzz, you know, just bzz, you can see it going across what the output of these things. I'll have 4 clusters of 5. One here, one here, one here, and one here. You find the hot spots first with just one, and then you make your clusters and you mount them in there. Now, you get a little spark plug, like a lawnmower spark plug. You don't need to see that. And you run it through the gap, right? And then you adjust that gap. And like I was saying before, you want that gap to be a very finite distance, and you'll actually create the electricity that jumps through over that gap, and you can put it right back into your battery running the motor. Not only can you charge a battery from taking the recoil of the coils. Oh, I haven't talked about that yet. That's the main thing. But you can also, so you can charge a separate battery, and you can also keep the battery running your motors up in volts too. So there's like no question about it being Overunity, that fact, that you can do both at the same time. So it's really a rotating battery charger. So now I think that's, oh, one more thing. Okay. Two more things. Okay, the generation. Okay, I'm going to go through the power generation systems. There's 4 ways this thing makes power as it runs. Okay, first of all was the splatter coils we were just talking about, what you can pick up from the stray flux that goes off to the sides. The second one, and this one has the most power actually, is you put a rectifier across the switch. Oh, thanks. And
Guess I'm fired. Guess I'm fired.
oh no, just okay.
Okay.
I'll get more stuff here. Here. Okay.
No, I don't need to. It's okay.
So here's some cores. I'll show you some cores. I'm going to give her something to do. She's getting bored.
No, I'm not.
So
Interesting.
here's ferrite tubes. Here's what I do for my cores. You get a steel bolt, and well, you don't want to see these anyways. So, okay, where was I at? Okay. First,
Second,
oh, the second one. Okay, now this is the way you charge a battery. We're just doing this. It's great. You take a rectifier. A rectifier is this little thing right here. And I'll tell you what a rectifier is. It's just like the rock band, AC/DC. There's these green wires. They're AC. If any of you don't know, AC current's what's in your house. And if you look at it on a scope or what it looks like in a picture or something, it goes up and down like this. It's a wave, right? Everybody knows that. They teach you. That's what they teach you, but that's what it is. It's wave like this, AC. Now DC is what powers batteries. If you want to charge a battery, you're going to have to put DC into it. DC is straight. Okay, AC, these rectifiers convert AC power, the green leads, into DC, the red and the black. And so you have no polarity on the green one. It can go either way. But on the output of these, it's red and black, positive, negative, right? So what I found is this is a DC pulse motor. Like I was just saying, DC power is straight. But this is a pulse motor. So every time you cut that power, you have this enormous spike. See, so it would look like this on a scope, oscilloscope, where it shows you what electricity looks like. It would go down a little bit, a little sawtooth shape. Now that means it's drawing current. Now all of a sudden it's cut. Bang-o! And then you get this big spike that goes off the screen. And then it comes back down, and then it kind of goes away, and then there's a big space, and then it does it again on the next pulse. A little downward one, and then bang-o! And then it comes down, and a little like this. So what's happening is DC, but it's turning it into a poor man's version of AC, because now you have stuff going up and below. So you've created, so these motors take DC power and convert them into AC. Okay, now what's important about that is you put a rectifier now across whatever it is you're switching it with, which in this case happens to be a relay. And you put those AC leads across this. This took me years to figure out. And when I figured it out, people were saying, oh, now you know the secret, you know. And so now all you are going to know this now. So now, now I'm taking the AC that this motor creates, and now I put the AC leads across that switch, and now I got this DC, and this DC is going to contain those enormous spikes. You know, that energy that's normally lost in electric motors, electric cars, any electric motors, that when that kicks back, that spike, it ruins things or slows down because it creates a force that's opposite of the force of the electricity going in. They try to get rid of it, they short it out, or they try to get rid of it somehow. But on these motors, because of these north-north coils, and other reasons, you can extract it and you can put it into a second battery and charge it up with it. And it's a beautiful way to charge a battery because the battery takes these spikes, just spikes it in, and so you can really charge batteries up. So the first. So don't forget, there's this one. These are independent forms of electrical generation. First, there's the stray flux on the side to get with this. And now there's the rectified recoil is what I call it. We get from this, and this is a battery charging. So you can charge one battery. Now one more thing. Well, and then the third thing is obviously it's a motor, so there's the shaft. You know, so how much power do you have from the shaft? And then the fourth thing is these red areas right here. Now this guy in, where was he from? Mississippi called me up or something, and he's going, you know, this is a while ago, he says, you got a pretty good running motor and you got north-north coils and you got a lot of power and speed, but every time you have a north condition on that coil shoving things this way, you have just as strong a force on the back side of that coil pulling towards it. That's just as strong. As you turn on a coil, it pushes, it also pulls on the back side. And I wasn't doing anything with that. So I goes, oh yeah, you're right, you know, I'm wasting all that energy, and that's 50% of your magnetic force, right? So what you do is you make your core longer than it needs to be. See this big red core here? And now behind your magnet, your electromagnets being pulsed, you wind windings just all over there, just back and forth on these. And every time it's like a magneto. If anybody knows what, it's very much like a magneto effect. You can also call it linear induction. So every time you pulse this, it rings this core, and it creates AC current again. And it just depends on how many windings you want to fit on there, how much power you have, like maybe 500 feet. This motor over here has, you see these things here? See how big they are, the red things? They are really coils only that big that draw the electricity inside of those. But around those and behind them, I've made these big, huge pickup windings. And now if I was to put a light bulb or some sort of load across this, that means it would be drawing more current, and you actually get more power out under load with these pickup windings. So that's something too that's also unique to this motor. So there's actually 4 electrical generation systems. If anybody gives me any crap, you know, I just skip to the next one, you know. Well, you don't think that works? Try this, you know. So anyways, okay, I think we should run it. Okay, so maybe we should, here, I'll pass these around, yeah. Okay, here's the splatter windings. Here's the, I call this a roller commutator. A commutator is something that a motor turns on and off. And here's a motor coil with a bunch of pickup windings on it too. See, only the black part up here actually draws electricity. All the rest of it is a generator winding that's independent. See, this goes to the battery, and these are power out. So, and I don't know if you want to pass that around or something, whatever. So, what else do I got? I think that's about all the stuff to pass. Oh, I'll just show you this. Now, I'm going to sell, so I got enough for 6 kits, and so I'm going to sell them. They cost me about 150 in parts. I'm going to sell them for 300 bucks. If somebody wants me to like build them for them but not do the electrical windings, I'll do 700 bucks. And if somebody wants to buy a motor, it's like 1,500 bucks, and that's American, right? So it's a lot of money, and I don't really want to sell them that much or anything like that. I don't really care, but if anybody wants them, I got them, you know. And and here's, I had all these pieces cut. I don't think I'll pass these around, but anyway, it's got all the pieces cut to this. This guy wants me to say I should have a money-back guarantee on this, but it's like, no way, you know. Forget that. And I encourage you all just to make your own, really. Just buy all the stuff and have fun, make your own design, because the basic thing is just like, you know, north coils, and anybody can email me. My email is Konehead with a K, Konehead@msn.com, MSN. Like Microsoft Network is what it is. And also Microsoft, you know, next time they have a monopoly, it'd be really good if they did something that worked, you know. Wouldn't that be great? That's a joke there, you know, a real joke. Okay, now we're gonna, we're gonna run this now. This is all exciting now. Yeah.
You said something about credit cards possibly getting emailed.
Oh.
What about all the equipment, the musical equipment?
Oh, that doesn't matter. No, it won't. No. In fact, I'm in a band too, and we take our electric guitars while it's going, and we go like this. It's really fun. And you can get all, because it's pulsating magnetic field, you know. And but when we use this big magnet, that's what I'm worried about. This thing alone, this is really small power. Oh, another thing, when you become Overunity, the power increase is exponential. It's like a scary thing. This is how you get into time travel if you want to get into that. But so what happens is once you get over that hump, there's nothing holding you back, right? So let's say you're running on 10 watts. Just say you're running on 10 watts. And let's say, let's put another battery or something and we make it 10 watts more. That doesn't mean you get 10 watts more if you're in the Overunity condition. That means you get 10 times 10, you get 100 more. So you can imagine some of these things are running on 6,000 volts or something. So you can imagine it only take a few stages before you're up in the millions of volts coming off of these things because it's exponential. So that's another reason. Keep your battery levels low, like 12. But nothing's going to break right now around here. Yeah, I know. Yeah, but when we get into these neodymiums, it's really incredible. Neodymiums, they're these really powerful magnets. I mean, really, they'll break your fingers, if you're not careful with them. And so we got one back here way in the corner, so it won't hurt anything. Now, when we do that, maybe we'll move things over just in case. But this guy did come up to me and say his hotel card didn't work when I did this thing in Dallas. What? Yeah, I know. That's not necessarily like this motor did it. But don't worry, look at me, I knew that would get a laugh. So there's nothing wrong. I've been around it. Okay, we're going to run this. Okay, so now, just so you don't think I'm a scammer or something, we're going to look at the volts on this thing right now and show you what it says. Oh, yeah. Okay, so what's it say there? So it's 13.03, okay? That's pretty charged up battery. This is a real neat Optima battery too. It doesn't have any lead. It's a really cool one. So we're going to call this the motor battery. The red one, this one is running the motor. This one is drawing this is where the electricity is being drawn from, is what's stored in this battery, okay? So nobody can go wrong with that. So now I have this hooked up. Yes, it goes. Sometimes things are all screwed up. Okay, now see how fast it's going? It's not bad at all. Now, this is probably dropped down a little bit because it's kind of like brings it down when it's running. So I would predict it's going to be like 13.01, I predict. I don't know, though, what it is now. Oh, 12.96. So it brought it down. Batteries are kind of a weird thing. Now, if you let a battery sit for a while, it'll go right back up to where it came. So anyway, so this is 12.95. It's going to kind of like cut the surface voltage, kind of let it drop for a while. I'll just leave these leads on here. Okay, so that's running the motor now. Now I get a second battery here. Okay, now everybody watch. We're going to show you what the volts are on this battery, so nobody thinks I'm ripping you off. And now, this says 12.61, so this is kind of a low battery. Now, watch this. This is what I was talking about. I have a little rectifier you get at Radio Shack. It's a 3 amp 50 volt, if anybody wants to know. This is for 12 volt. If you step up the voltage, so, fuck. Sorry. So we're running on 12, but if I put 24 volts or 36 volts, I'm going to have a different size rectifier, right? Because I'll probably blow it up. Okay, so everybody see these green? Go right here on the switch. You put it across the switch. That takes all that spike. Right now, that spike is actually slowing this motor down a little bit. Now we're going to charge this battery over here. Here's red and black. There, see? So. And now, what was that before? 12.96? No, that was 12.61. 12.61 on this one. Okay, yeah, hear it speed up? Yeah. It speeds up because now and it blows cold air. It never makes hot air. It's really amazing. So, so what's happened is that back force that I'm always talking about, this is actually a backwards generator. You could describe it as. It puts energy into a coil, you cut the coil, it comes back. Okay, now what's happening before we put these on here is that back force is actually colliding with the force going into the motor. And it was slowing it down before. It was creating a back EMF force, which is what all motor designers always want to design out of their motors and stuff. But it's because they're all stupid. Because what you want to do if you read any books, conventional electric motors, they attract that rotor. It's always an attraction mode, attract. Now this thing is, and it creates a transformer effect. What a transformer is a winding here, you know, and this one induces current. You can put it in here, it comes out here, you know. So it creates a transformer effect, and it kind of locks it up. And then when you cut it, it makes this horrible force that goes backwards to everything, and it bogs your motor down. And that's because of the stupid way they design motors right now. Now when you have this colliding north against north, you don't get any transformer effect. It's always hitting away both ways. It'll never go like this. It's always away. You don't get that. And you also get that compression and then the release, just like a pogo stick. Compress it down, then bounce way up high. So this makes a lot more voltage, like a German or something on his textbook. You know, he'll go, oh yeah, well your coil should only make so much in back EMF, you know. But now what happens when you collide a coil against a coil, matching coils with colliding fields? You don't get anything they have in the textbooks. They don't even have it in the textbooks. So that is all going into here. Okay, now, here, excuse me. Oh yeah, okay, now remember this was 12.61, right? So now it's 0.
You got to put these on.
Okay.
I can take these off now.
Oh yeah, here. You can
Clip them on?
just clip them on.
Okay.
We should get a battery terminal on that other one. Here. Then you can have something to clip on it. Yeah. Okay. Now watch how it speeds up when she puts this red one on there. See, it goes up quite a bit. Now also now that it's been sped up, now your timing is going to be different, just like a car. In fact, this motor at low speeds, it won't even run at the timing you need for at high speed. So you got to have adjustable timing. So now I'm going to adjust this plate a little. So I'm slowing it down. You want to find the sweet spot. Right there. I don't know. That's pretty good there. So you can really you really fool with these things to get them to go right, to find something's going on here. Okay, trying to find the best. That sounds good right there. You really want to adjust that with some meters. So like you look at your current going in and you adjust it. It's not necessarily what sounds the best or looks the best or is the fastest. You want to see the exact timing that makes your lowest draw into it at the same time or the biggest kick out. But right now I'm just doing it by sound. Okay, so that was 12.61. So we've been charging it for like 5 minutes or something. So it's probably about 12.65 now. It's gone up. Now you red, yeah, and black. So what does it say? 12.67. It's going up. It's going to always go up. 6.8. So that's not that much. It's only gone up, a fraction of a volt. But over an hour or so, this is going to be way up. So right now I'm running off this one and I'm charging this one. This alone makes the motor way better than any other motor because you're charging a battery. Now obviously all you'd have to do, if you can charge this one faster than this, then all you got to do is after like a half hour or something, you switch batteries. Now you run off this battery and charge up this battery. After another half hour you switch batteries. You rock batteries. And then you can have it running forever in your closet or something. And it would never go down. It just rocked the batteries. And you can charge up more batteries. You could have all these pickup windings I was talking about to go over here. Now it's taken off pretty good. Yeah, that's sounding pretty good now. So also these pickup windings here, you can wrap all these windings here, a big old blob of windings. Run that into another battery. First you rectify it. It's AC coming out. Put it through a rectifier, charge another battery. Put another battery over here, pickup windings, charge that. Put splatter coils on it, charge this, then maybe put a generator on the shaft. So there'd be like, 6 batteries charging up. Plus you can keep the one battery running the thing from not ever going down in volts by using those splatter coils, by running that high voltage spark back into the battery. So it's a pretty good contraption, really. And you can, so rotating, and remember, yeah, it's going to ruin the world. So, yeah. And, okay, we're going to have some fun now. We'll do the neodymiums. Okay. I got another one, but I don't know where it is. We were going to do 2. Here. She's the expert at this. Okay, you want to always hold these really tight, just and then wrap it in a rag, and so it won't fly away, you know. So that's what she's doing. Now watch what she can do with this thing. I'll take a break. I just discovered this like a couple days ago at this guy's house. Oh yeah, hey, you want to try something? Oh, I better not do that. Okay, there, here it go now. Listen to that baby. And yeah, and I think this is just something new because I've never really wanted to use these because they're dangerous or something. I've always wanted to make this simple, but they're fun, so I just got one. And you know, but I think what's happening here, okay, the rotor's going this way. This is all theory. Listen to that. It's amazing. And you could, yeah, that's what you're thinking. You can have this as a controller. You could have it just kind of move a little bit with your foot pedal or something like that. And it's the position is like within a millimeter, you know. You have to be really precise when you find the position. We can maybe have people come up and try this for themselves if you want, if you have to be careful about it. Just make sure you get a good grip on there. And you can actually just make it break. See what she's doing now? Because it's all of a sudden it's doing something wrong. But here's what I think is happening is that field's going around like a weed whacker, you know, in a certain direction. Listen to that. Oh yeah, a flywheel would make a... Yeah. Yeah, I know, just like, because I just saw his motor, yeah. Okay, he's talking about what he was just saying is what you do is you take these huge, this is what this guy around here does, I'm not supposed to say his name, right? And so he takes these huge magnets, he puts like 12 of them in a flywheel, like, you know, and, you know, like every number of the clock, and he puts them around there, and then he takes, that's an even number, then he takes an odd number. For some reason this even odd is the trick to this, because, yeah, this is another motor design, weird. And then you take odd number of coils on the outside, on each side, this side and this side. Hey, we got someone now, good. Okay, yeah, hold it just like, you know, like, it's, yeah. And don't ever let loose. You're never supposed to like, hey, here's the magnet, you know, just, yeah. They really yelled at me about that. I got another magnet too, and see, for whatever if he's put ones here, you can put one opposite too. So I don't know where it went though, but we'll find, it's in a little green and white box. Maybe it's in here. But anyways, so this is kind of fun. There, see? And also, let's see what now this is new stuff we're doing right now because I don't really know if it's going to make it charge better. Yeah, see now that's gone up to 12.77 already. And if you've ever, like a car alternator doesn't even charge car batteries that fast, I don't think. As far as I know, you know, it usually takes a while for it to go up that high. So, I'm also worried we're going to get it to go so fast we're going to blow up this rectifier, which is really possible. So, okay, so now I don't know what else to do.